Hello everyone, my name is Emre Kulkul. I'm a student at Bilkent University, and this is a video for my EEE102 digital design course project. My course project is Monophonic keyboard synthesizer. So let's explain a bit about how the project works. So basically, this is my enable switch. I have two octave switches here. They will change my octave according to my desire. This acts as a 4-to-1 multiplexer. When it's 00 selected, it will display the octave number here, which is 3 right now currently. If I increase it, it will be 4, it can be 5, and lastly it can be 6. For the sake of this experiment, we'll just use the 4th octave. This right here is my sound output. This is where my sound travels over here with a jumper wire to this GP21 hole in my TRC11 circuit. This is the amplifier part of the circuit. It amplifies the voltage given from here, given from sound output, and the voltage gained output will transfer to my loudspeakers with an aux cable, and hence sound will be generated over here. So the 7th segment only displays the octave number here right now, but it will show when I play a note the currently played note over here on these two segments, on these two digits. For the sake of this experiment, I could not make a hashtag symbol on the 7-segment display because it's practically impossible. So I just resorted to using H as my hashtag symbol. Let's move in on how the sound is generated. I specified 12 notes, 12 keys as my notes here. So let's just show by pressing some of the keys. If I press Q, nothing will be played because I didn't specify any notes for that. I only specified notes for these keys from 1 to this button over here, this symbol. So let's press 1. I should increase the sound a bit. Right now, you can zoom in on this. Right now, I keep pressing 1, and consequently, the note I specified for 1, which is a C, is played here. I'm in the 3rd octave right now. I can switch to 4, 6, and 5. Let's just stay in 4 for the sake of this experiment. Also, the LEDs over here, you can zoom in on this. The LEDs over here, they're specific scan codes generated for 1, which is the key I'm pressing right now. So now we should talk a bit about how UART was implemented in this project. UART is a standard communication protocol that suggests that the communication line is held logic level high, which means the code is in idle state, waiting to receive a data bit. When a start bit, logic level 0, is encountered, the code shifts into the finite state machine created specifically for UART, shifts into data receiving mode, where 8 data bits are transmitted from the laptop keyboard to the bassist tree board. We load these 8 data bits, which we receive serially, 1 bit at a time. And when all 8 data bits are received, stop code is sent it's transmitted from the laptop to indicate and alert the finite state machine that data receiving state is over and that we should be shifting back into idle mode, awaiting for a new keystroke to occur. So let's now show physically on the bassist tree board the 8 data bits I mentioned. These 8 data bits have a special name. They're called scan codes. while we're talking about a keyboard communication protocol. So let's just show a few examples of different scan codes. I should mention that all the different keys on the PS2 style keyboard produce different scan codes. No two keys could produce the same scan codes, so they're special for each individual key. So let's show a few examples of them. I didn't connect my sound output, but now I'm going to transmit some signals and you're going to see different scan codes appear on these LEDs over here. So right now I'm pressing 8 on my laptop keyboard. This is the scan code produced specifically for 8. Now I'm pressing 6. You can see that it's different. K, which is not a note because I didn't assign it, but it still produces a 8-bit scan code. Now 3, L, 0, M. And as you can see, all the different keys I pressed produce different scan codes. So what use is a synthesizer if you don't use it to play music? So my friend Eda over here will now play Ayla Dickman's song Anlamazdın. Enjoy.